All right. Now, big thing about integration is if we don't have a formula, which I want you guys to memorize and recognize those formulas, or right now if we don't have the ability to do U substitution, those are our two big methods for integrating. There's another method, integration by parts, which is like a Calc 2 type of idea or a BC idea. Uh, the, the problem is sometimes we'll get into functions or relations that we can't actually integrate. And once we get into that situation, then to actually kind of figure out what these solutions are to maybe a differential equation, because last time we met, we talked about separating a differential equation, get your dy's and your y's on one side, your dx's and your x's on the other side, integrate both sides, and you can actually get a relation or a function of some kind. But now, when we get into weird things, and we don't necessarily have weird things, but sometimes you're going to be given weird functions where you can't really integrate them. But we can still figure out what these solutions are going to look like and kind of deal with them and get what we call a slope field, which will show us, or at least give us a framework to get a picture of what these solutions are going to look like. So this is what I gave you is notes that I created yesterday, or at another time, about how to generate a slope field, but I think it's best if we actually see what we need to do. So I gave you a couple different worksheets. But what I want you really to do is I want you to take out this. Let me get one that isn't water stained. All right, so when we're talking about slope fields, and if you have to generate a slope field, you're not going to have to generate much more than if we have 0, 0, 1, 2, 3. You're not going to have to generate a lot more than that. But let's take a look at, for example, we're going to generate a slope field for we'll do a simple differential equation. We'll do a simple one. And here's a simple differential equation. And well, we're going to go through step by step how to actually do this. So you're going to want to have this, like maybe put it on the back of one of the worksheets that we have, or something like that, just so you have these different ideas. Now, this would be a little bit harder to actually come up with a really good way of integrating this. However, we can create a slope field based off of this. The biggest thing is dy dx is your slope at any xy point. Now, the easiest way to go about doing that, and since we're going from -3 to 3 for x and 3 to 3, there's a lot of these different points that are up there. So the best way to do it is one, creating a table, and two, doing everything sequentially. So if we do this, we're going to create, and this table will go on and on and on, but we'll only work with, for example, let's start with the first quadrant and figure out what we need to do. Now, if I take a look at x equals 0, I could get 0, 0, 0, 1, 0, 2, 0, 3. And I'm just working right here for right now, just to give you an illustration of how to create the slope field. That would be 0, 0, that point right here. 0, 1, 0, 2, 0, 3. So what we're doing is we're actually figuring out these different points. And that's why we use a dot, a coordinate plane with dots at the specific points. Because then we could go 1, 0, 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3. Forgot 2, 0. So I'll put 2, 0 in there. And then if we go to 3, three 0, 3 1, 3 2, 3 3. Now, since dy dx is going to represent the slope, what we want to do is our slope here, dy dx, at any point on our solution, and that's what this is. So whatever the solution actually is going to end up looking like, dy dx is going to represent the slope of the tangent line on those different points. So we take the whole idea of dy dx as being the change in y over the change in x. Now, it says that our slope is equal to x plus y. So
where did you get all those numbers from?
they're every single point that's in the first quadrant and on the x-axis. So that's like 1, 1, 1, 2, 1, 3. So I started here, and I picked these 4 points, these 4 points, these 4 points, and these 4 points. Those are represented by these. So when you're creating a slope field, you have to actually look at every single point and calculate a slope for every single point on the graph. Now, when I've seen different slope fields that you have to generate on AP exams, usually it's even less than this. It's like just like that. So it's not horrible as far as the different values you get. But creating the table of values makes everything easier. Just add the numbers. That's 0, 1, 2, 3. 1, 2, 3, 4. 3, 4, 5, 2, 3, 4, 5, 6. Yeah, you would have to do them for the entire picture. But for right now, we're just figuring out how to actually draw the slope field. It's not that bad. It's not that much work. Oh, a lot of room. Well, now, what you want to do when you draw these, let's take a look at, for example, at 0, 0, the slope is 0. So what I would do is you draw a segment. Hold on every once in a while things freeze up. What you're going to want to do is you're going to want to draw just a little segment that's going to represent the actual slope. Now at 0, 1, the slope is 1. So if the slope's 1, you'd go up 1 and right 1. So the slope would actually look like this. But we're not going to draw the whole thing. We're just going to draw a little bit. So we don't draw the entire thing. At 0, 2, the slope is 2. So it'd be up 2 and over 1. So here's the slope at 2. And then at 3, would actually do this. So a horizontal line, and this is why I'm not doing the whole thing. If you see a horizontal segment, your slope is 0. And now you can tell that the slope is increasing at every point here. So I've taken care of those first 4. If it's undefined, you would draw a vertical segment. Yeah, the slope would have to be undefined. This is getting close to being undefined. You can see it's getting there. Eventually, it would be undefined. Well, maybe it might not be. It'll get very close to it, but not necessarily. So we go over to 1, 1, and that slope, or at 1, 0, the slope is 1. So yes, this gets a little bit tedious. This is going to give me a slope of 1, because to get for a slope of 1 from this point, go up 1, right 1, and so that's rise over run, 1 over 1. So I know I'm going to this point, so that would be the line if I drew the entire line with a slope of 1. I just need a little segment going through that point that has that slope of 1. So the ruler represents that slope of 1. Now here I have a slope of 2, which means up 2, right 1. So I know I could get to this point, and then I can just draw this. Now for 3, I can't really go up 3, so I'll go 1, 2, down 3, and left 1. So I know that I'm going to go through this point, and I'll draw that. And then here it's 4. So 1, 2, 3, 4, 1. Yes. Right, I'm getting the slopes from these values. So I took care of my 1s. Now I'm going to take care of my 2s. At 0, I have a slope of 2, which would be up 2, or right 1, which would get me to that point. And 2, 1 is at 3, so I'm going to have to go down 3, 1, 2, 3, and left. Then 4, 1, 2, 3, 4, and here, so and 5 is going to be like that, and then I get the 3. 3 has a slope of 3, 1, 2, 3, 1. Then I have a slope of 4. 1, 2, 3, 4. So it's there. 5. 1, 2, 3, 4, 5. There. And then 6 is even more crazy like that. So as you can see, things are kind of getting a little bit more vertical. Then we'd have our, if you had our negative numbers, you'd get different numbers there. Now the neat thing about the slope field, once you get to this point, what they do is it creates kind of like alleyways. If you're starting here and you're saying, I want the solution that contains the point 0, 0, you would actually kind of draw a line that would mimic what the slopes are going to be. And so this would be a general solution. We don't, or actually that's a particular one.
How do you know how far up to go?
You just keep going through the slope field. You go through the entire slope field.
I know what I'm saying is like, how can you go like set?
Think of them, it's like, I always think of slope fields like bumper pool, or bumper bowling. You're creating alleyways. So for this, I know to get to this point, it's going to have to get to this. So it might go through this and up, or it might go through that and up. So you can kind of see the different solutions are still, like this guy right here is kind of doing that. A solution down here would be kind of doing this. This one is kind of doing that. So the solutions are all very similar to each other because they're all increasing like this, and eventually they're going to increase to almost being vertical. But with the slope fields, what you want to do is you want to create these, and then you can kind of figure out exactly what's happening and draw these. What was that? Well, yeah, you would end up drawing all of them. And if you have to draw more, if you have to actually draw the whole thing, you're going to be given less than what I gave you. It might just be, like down here, you just might have to draw the slope field through here, just to get an idea what's going on. And so that's a whole lot less points than the number of points that I gave you. Yeah. No, you have to do the entire thing. I just showed you the first quadrant to give you an idea on how to actually draw it. Now, given that, I want you to, and honestly, there's nothing else to slope fields besides that. That's how you create them, and they just represent the